Welcome everybody. You're watching Mr. Fugu Data Science. We're finishing up our Indeed job postings today, doing a few word plot examples, and I'm going to illustrate some of the hiccups that you're going to see when you're doing this. Thank you to the recent subscribers and viewers. I really appreciate it. Thank you for your support. Now hit me up on Instagram or Twitter. The code will be in the link in the description below from my GitHub. I've also provided a buy me a coffee. I'm sorry, shameless plug, but I gotta do it. I spend a lot of time on these videos. Let's get into this. Here's the imports you're gonna need today, so feel free to pause the video or throw down on my GitHub so we could be on the same page, okay? We're going to call in the file that we used from the web scraping so you can see what's going on as a recap for those who haven't followed along. What I did was originally web scrape these data from a few days ago, which was either the 8th or 9th of October 2020. We were looking for postings of data scientists in California, not in a particular city. These are the data we came up with. It was 225 entries. Today what we're going to use is this qualification text. Now, this text was processed in the second video using natural language processing, which will be in the card above if you would like to visit that first. There will be a link for the web scraping as well. Now, this skills match will be used in our second distinguished word cloud. These came from a list of keywords that I put in to do a comparison against these texts to see what skills were utilized for these positions. And as a spoiler alert, if you pay attention, Python is something that comes up quite often. For those who are inclined to disagree, I can prove you wrong. Now, let's get into this. We have our first example printed out here for our qualification text so you can see what the job posting looks like. I mentioned some discrepancies and some things that you can actually achieve better results with if you were to do this again. If you are interested in that, please look at the previous video for the natural language processing, okay? So the column that was used for the second word cloud that I mentioned above that comes from this file of skills, distinct skills that were matched. I just want to reiterate this for the one person who may or may not be watching who doesn't like Python. There you go. Okay? Because Python. Anyway, enough messing around for now. You could go on either of these on my GitHub and pull the files directly, okay? This file is what we used to store basically the natural language processing. This is what we're going to extract today to create one large string from this list of strings, okay? So let's convert that real fast so you can see what I'm talking about. Okay. What I just did was I'm calling in this particular column because that's what we're going to use to store everything as a big string. And I wanted to figure out what the type of this is to see if I can convert it now or if I have to iterate once again. And that's what I have to do since this is a list. This is how many words. I don't think it's characters. I think it's actual words that are in each one of these entries. Okay, so this is going to be pretty big in the tens of thousands. Okay, let's iterate once more. So I iterated and I stored it, but what's really going on here? We need to do a string join for this list of all of the strings. Let's get an idea of how long this actually is. Okay. It's pretty big, 67,000 for only 200 entries after we did all of our data cleaning for the NLP. Okay, fine. Okay, we stored this whole thing as one big old string now. So we'll be able to use this within our word cloud. But let's get an idea of what's really going on inside of this word cloud, okay? Basically what's going on is, a few things. First, the matrix that we're dealing with, if you're deciding to call in an image to basically have some image that's going to have the silhouette of all of your words storing in it, so it's not just like one big blob. You're going to have two things. One, if you have a printout and it's all zeros, it's going to represent black, and 255 is white, and then anything in between are other colors, okay? So that's one thing if you're messing with these images. The second, and that's when you're creating a mask, and that's what's going on. When you're creating the word cloud object like this is where you actually put in all of your parameters of what you want it to print out. So let's get into what's really going on. This is an actual example right here, if you're curious. So now we have our image that we are going to use for our mask, but let's see what's going on here. This is going to be a triangle that I just created. So everything is in 255, okay? Now, what do? We're going to create our word cloud object. So what did I do here? I want a background color for the image to actually be black, okay? Max words I want to be 850, and you can understand the rest. The random state though, think of it as like a random seed. You want to generate the same image each time. I'm normalizing the plurals, and then I'm throwing in this mask because I want the image to be in this triangle shape, okay? Okay, the only thing you should just pay attention to really is this right here. So you can call in your word cloud object and then interpolation equals bilinear, and you don't need any axis. That should be self-explanatory. Now let's get this and see what's going on. Okay, that looks pretty good. We got it in a triangle. We could see a lot of things. We could see some things that are related to Python, which is good to see. Data scientist, analyst, statistical analyst. Okay, cool. We still got to do some processing to take some of these words out of here. So we'll do that in a second. But what happens if you didn't have this triangle and you wanted to plot this off? Let's see what happens. You see it just becomes like a jumbled thing. There's no order. Doesn't look like anything really. Okay, let's do this word cloud, but let's think about something. We have a few words that we need to actually get rid of, okay? But we're going to do that in the next step. Let me show you what it looks like for our good old skills section. So pay attention to this. I went into my data frame that took just the skills column, and I had to convert it into a string from all of the columns that were lists of strings. I ran the same thing just to cut and paste from what we just did above. Only thing that's different is just this right here. I don't even need this, and printed it off so you can see. If you see here, these are the most relative words that we came across from what we had from the list of comparison words. Something I mentioned in the last video, the SQL, there are varying forms of SQL, and to do some further processing to get more granular, I would suggest using regular expressions and looking for anything that contains SQL in it, before SQL, any previous, like a look back, okay? Then that will give you the various forms of SQL so you can have an idea of what specifically they're looking for. Now let's get into what further words we need to deal with, okay? Because we have a few things of interest, but how do we actually start plucking out things that are unnecessary, okay? So what I did was two things. First, you can iterate through and find word frequencies and sort it by the most frequent, okay? And you can notice here that data, experience, science, things like this are going to come up everywhere, because this is basically the data and the science or analyst is basically what you're looking for the job title. So that's obviously going to be in the qualification stuff. They're going to have related words, bigrams and trigrams, and that's another thing that you can use for this word cloud and any other plotting is instead of taking individual words, start doing bigrams and trigrams. The only problem with that is the amount of memory it starts taking doing those kind of computations. So just be aware of that, okay? The other thing you can look at is individually look at this word frequency or in conjunction with the above word cloud that we looked at first, pluck out individual words that you think are useful, okay? That are irrelevant, all right? Things you just aren't gonna. And what you can do is go through that list here and compare it with what's in your string, and then just replace each one of those word occurrences in the list you just created with an empty space to get rid of it. And then you just generate the same word cloud once again with the revised version, and it's not perfect, but does get rid of a lot of things. And you'll notice, oh wow, go figure, San Francisco is extremely important and relevant for the tech sector. Never would have guessed. You still have the data analyst, scientist, and science. That would be something you could actually discard and see what other words that you have come within this. And you could play around with sizes, the amount of words, and see how this actually changes, okay? But you still got your pandas and your scikit-learn and your machine learning. Next thing we're going to do is look at how your images can affect your actual plotting when you're doing this. And this is something that you need to be aware of when you're trying to exploit your customization of plots. For instance, you can have a black and white plot, but as soon as you start adding in colors, now you have more channels to work with, and you could do varying color mappings, such as this right here. All right. You also have situations where you may need to invert and do like change a white to black or black to white, depending on your image, because it may not show up, or it may show up and just look like a jumbled piece of junk. So this little transform function, I found it when I was scrolling through looking at examples to get some ideas, because I had an idea of what was wrong with my image. I just wasn't sure how to deal with this because images are not my specialty. So convert everything from 0 to 255, and we need to return this and change our NumPy array so we can remap remap this and plot it out. So what I'm taking is this computer, this cartoon computer, and this cartoon computer is interesting. I'm going to show you why. Let's first scroll down and kind of get an idea of what we're looking at. I'm calling in my image. This is a new NumPy array that I'm manipulating because now I'm taking the dimensions of it. So think of taking the dimensions of your matrix, converting this to an int32, and then you have to map this together. Just think of if you were doing like a list of lists situation and map everything together like that. Okay, you want to retain the correct dimensions. And after that, it's just a basic plug and chug of what we've had before. Okay, and it actually turns out pretty cool. Let me tell you something. If you're not working inside of your current working directory, which is why I can call this directly, you're going to need to call like the OS path and then just find wherever you're looking for this right here and just change that to whatever it is. Okay, so just be aware of that. Now, this is going to be interesting because it prints the outer perimeters of like basically tracing what the computer looks like. Okay, and while this looks kind of cool and you can see what it's trying to achieve, I mean, is it particularly useful? Not in this application, not with these data. You know, it gives you an idea, but it's too sparse, the spacing. Maybe if you had a lot of words that you could fit in here to make it really take up the detail, then it might look better. Using this same computer, we can take it and add our coloring. Okay, so we're basically using the recoloring, and you just plug in right here what you're using for your mask. Okay, and everything is the same. This is the only thing that's different right here, this line. Let's go in here and look and see, okay, this is actually coloring a specific spot different from this other portion of this computer. Now let's look at what this computer image looks like. Here's what the computer looks like, okay? That's why you have this blue and this gray. The next thing that we're going to look at are these two things that are kind of interesting. You have this cloud, which is white with a black background, and we have to change that. And then we also have something that kind of screws us up, which is this white with this just black line, this bold line separating it. And that causes us problems, you're going to see. So we have this black border for that cloud I just showed you. And I didn't do any kind of formatting. I just plugged it in directly to what we're doing above. Only thing I'm changing is this right here for the image I'm calling in, and I'm just chucking it in for the mask, and everything else is the same except you just change the title so it's relative to whatever you're doing. I didn't print this off yet, but we can print it off so the name changes at least. This is kind of a problem for this one, and I tried remapping it, and what happened was it only printed off a blank page, so that was highly irrelevant and useless. While sometimes it doesn't work out, we can do some transforming, and it does look pretty cool. So let's look at an example of that. So we do our little transform that we were doing above for our dimension. We're iterating through it using our mapping of the formatting function we did above, and then our mask that we're iterating through, and then you're storing it in the correct positions with this and calling it in, and this is now your mask with your transform data, and everything else here is the same. Okay, and let's look at this. This is a different cloud. This is the cloud that had the white here and the black here, and this one looks pretty cool actually. It has a lot of words, more than the triangle. We can kind of zoom in and get an idea of some of the stuff that we may not have seen or picked up earlier. Okay, so it looks pretty cool. This one's my favorite so far, since it's relative to what we're doing. A word cloud. The other thing was a triangle, which I thought was funny. Think of like a pyramid scheme. And that's a joke to my one person who doesn't like Python. But as always, like, share, and subscribe. And if you subscribe, turn on that notification bell. Now it's time for our fun with our satire. So once again, you see, here's me when you put it in YouTube. And you scroll down. And guess what? After 3 days, 2 days, whatever, the troll's still there. But look what happened. You see my name, you see my image, but he changed it to his name and he kept my image. And if we look up here, still the same information, still the same little person. Get a life, change the picture. You're not me, you're not gonna be me. Get over it, get over it, get over it. Get a life, get a life, get a life, get a life. There's two songs that remind me of you. One of them is called Stan. You could figure out who the artist is. It's really famous. And then there's another song. I won't say the title, but I'll tell you the artist. And it's called Buck Cherry. And it's called Crazy. And you could fill in the other word. You could look those up. But those are what you remind me of. So thank you for being a hyper groupie. I appreciate it, because I guess I'm supposed to take it as the best form of flattery is imitation. Except this is impersonation. So have fun with that, goofball. Also, in the future, if you got some common sense, and stop impersonating me.
Because you're still impersonating me.
So I'm pretty sure you're going to have to fix this from YouTube's point of view, since it's in the community guidelines. Moron, 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 moron. Have a good one. Bye.